Now, we want to look at situations where we've got two events occurring at the same time or after each other, or that we have to get the probability for here. And we call these compound events. So what we use a pretty simple one to show as our example, like the idea of tossing a head on a coin and rolling a 6 on a die. So it's easy to see our sample space because we can toss a coin and get heads and then a 1 or 1 to 6, or we can get a tail with a 1 to 6. So probably of a head and a 6, well, that turns out to be 1 out of the 12 different combinations there. We can see how we can do it with just the probability there. And the idea that the probabilities here don't affect each other as well. So we're using the idea that pick up some of the language. So the idea that an event from A to occur and an event from B to occur, we get this situation, we start to multiply our probabilities. So generally in our probability there, and means to multiply. So if we can see specifically, explicitly and, or have an implicit and in there. So if it might not be written down, but if you read something as a probability of something and something else occurring, then you've got to think multiplication there. So we have a look here at some examples. Two dice with 0 to 5 on their faces. What's the probability if they both show 4? Well, probably of a 4 and a 4. Well, on the first dice, it's 1 in 6 chance. In the second one, it's 1 in 6, so 1 in 36. 2 here, we got a 12% probability of a television breaking down. We got 2 of the televisions. What would be the probability of the breaking down? And notice I don't use and, but I've got a probability of a television breaking down and a television breaking down. So there's an implicit and in there. I don't have it written down, but really when I'm saying the probability, it's T and T together. So notice the and in there. So the 12% times the 12% gives us a 1.44% chance of that occurring. So be really wary of that implicit and there. So if there's 100 tickets in a raffle and Lee buys 3 tickets, find the probability of Lee winning first prize. Well, 3 in 100. First and second prize. Well, the probability of a win and then a win. So if Lee buys 3 tickets and has 3 tickets out of the 100 to start off with, if he wins the first prize, then the second prize, well, he's only got 2 tickets left, and there's only 99 tickets left in the raffle because the first ticket usually gets discarded. So we've got to take that into account. Now that's a case where there's no replacement in our probability. So we've got to be wary of that as well, which gives us a 1 on 1,060, 650 chance there. And this time we've got bag containing 5 white, 3 red, 6 yellow balls. 2 balls chosen at random. Find the probability there with a red and yellow ball. So the probability of a red and a yellow. So notice that we've got red and yellow ball, red and a yellow. So it's written in the question here. Red and then a yellow would be 3 on 14 and then 6 on 14. Now that's if their ball is replaced. So if you get a ball being replaced, we get that. If there's a problem with the red and then there's no replacement, then the sample space goes down by 1 and we still 6 yellow, so it gives us a different probability of 9 on 91. So notice a little bit of change depending on if there was replacement or no replacement. So we've got to start to be wary of all those different situations occurring with our problems.